Hi everyone, you're here with me at another Kane County Forest Preserve area. Now this historical site contains, as you can see behind me, a windmill. That windmill was built in 1850 or between 1850 and 1860. And as you can see, it's still standing. That means it's a strong structure, which we're going to be talking about today. Now, this strong structure is also 21 meters tall. That's a lot. It's about 5 stories tall. And windmills had a purpose. They had to grind down wheat and flour, and they had to be strong, and they had to be strong enough to withstand the wind that it catches to do those things. So as blades spin, it actually spins a huge heavy stone on the inside. So everything has to be nice and strong. Now, this windmill didn't always exist here. They actually had to move it from Lombard all the way to Geneva, where we are now. The job or the purpose of a windmill is what drives the design and what drives the materials that we use to make it. Now, this windmill, like I mentioned before, was used to grind down grains to make flour, which we use to make bread and other things too. It's really important if you're helping bake in the kitchen, which you could do. Now, this windmill has a huge stone in it. It's about 1 to 2 meters big, and it has to spin around in a circle on top of a hard surface. And so, even though some of the strongest people that you can think of, the strongest people in the world, can move heavy things, they're not strong enough to actually push the heavy stone. So they have to come up with a different way to do that. And back then they used a windmill. So you can see the blades at the top. Those catch the wind, spin some gears on the inside, which actually spin the stone. And that has to be pretty strong. So they use some really strong wood on the inside, along with the really strong blade materials to help do that work. Being strong is super important, and sometimes the material makes all the difference. Selecting the right materials is one of the most important steps of the engineering design process. So when architects design or create structures like the windmill, they have to think about the properties of each material. What's its hardness? What's its flexibility? That means how it can move. What's its strength? How strong is it? How much weight can it hold? All of those things are super important to know when they build. Now, this was built almost 200 years ago, so they didn't have some of the fancy materials that we have today to build. So you can see behind me, some of the design was done with wood, a little bit of metal, some concrete. And so they had to work with stuff that didn't exist way back then. Although there are some newer updates because it's been around for almost 200 years and a lot has changed. We have new materials and engineers keep coming up with new materials. Bridges are an important structure, and they actually link yesterday's Japanese garden to today's windmill. So bridges have to be made out of the right materials and be strong to withstand a lot of forces. So this bridge is used for people to walk across, bike across, and connect 2 different paths that you can take out here. And then also it has to be strong enough to withstand wind and withstand water pushing on it. So that's a lot of different forces they have to take into account. So if you look, it's made out of pieces of wood, metal, it's got concrete at the base to make sure it's held in place, lots of strong materials. And they have to think about the size of those materials. A strong material can still bend or break, so if you look, they use pretty thick metal. So not just what type of material, but how big of that material they have to use it to be as strong as possible. It's your turn today. You are going to design something that is strong by testing some materials. You're going to be designing a bridge using the sheet that I provided or creating your own test sheet. And I want you to pick 3 materials that you think might be good options, might be bad options. So if you need some support, you can use a paper towel, your plastic math sheet, a book, anything that you can think of that's long enough. You're going to need 2 cups to act as the end of the bridge and put your paper or your book so that way it spreads across those 2 cups. And then you're going to add coins to see how many coins it can hold. At the end, I want you to think and then answer which one you think is the strongest and use I think because. So maybe make a prediction beforehand using that I think because, and then share with someone.